Alright, so this video will review the different methods that we have learned for solving systems, and I'm going to talk about why I'm choosing each method and then show you how to solve it. So in this case we have two equations in standard form, and so the easiest thing to do is elimination combination. So at this point I can't eliminate anything because even though these have the same coefficient and these have the same coefficient, they're not opposite signs. So all I need to do is multiply one of my equations by -1. So it doesn't really matter which one. So this would become negative, this would be positive, and this would be positive. And then when I combine things, this would cancel out because it's a positive and a negative. This would cancel out as a positive and a negative. So this side I have 0. And then 6 minus 13 would be -7. So I have 0 equals -7. That is not a true statement, so this actually has no solution. So these two lines, because it has no solution, would have to be parallel, so they're going to have the same slope and different y-intercepts, and it's just no solution. Moving on, number 2. I have one equation that's set as y equals and another equation in standard form. So since I have one variable isolated here, then I would just use substitution. So I know that my y equals 2x. So wherever I have a y in my equation, I replace it with 2x. So I have 4x plus 3 parentheses 2x equals 30. So this would combine. 3 times 2x is 6x plus the 4x. So I have 10x equals 30. So x equals 3. And then I'm going to replace, to find my y, I'm going to replace this x into, you could use either equation. This one seems simpler. So y equals 2 times 3, which equals 6. So my solution here would be 3, 6. Number 3. Two equations in standard form. I don't have any coefficients that are the same. I don't have any opposites. So this is where I need to choose one of my equations to multiply, or both. In this case I can do just one. What looks easiest to me is to multiply this top equation by -4. And my goal is to then eliminate the x's. So I would have -4x minus 8y equals -16. Don't forget you have to multiply each term. A lot of people forget about this last one, and that's going to mess you up. So I have a 4x and a -4x, which would cancel. Positive 5 minus 8 is -3y. And then -20 and -16 is -36. Divide both sides by -3. So y is 12. In this case, again, you could use either equation. Just because I've done this a lot of times, this first one is going to be easier because the x doesn't have a coefficient. So I'm going to use the first one. X plus 2 times 12 equals 4. 2 times 12 is 24, so I'd subtract 24 from both sides. So 4 minus 24 is -20. And then of course at any point you could always put your x and your y back into an original equation to then be sure. And I'm kind of estimating this here in my head, and -20 times 4 is -80, plus 5 times 12 is 60, so -80 plus 60 is -20. So I know I got the right answer because this plugs into this equation as well. Number 4, I have a variable isolated, which means any place I have an x, I can replace it with the value of x. So y plus 4 replaces x in my equation. Now I need to distribute. So 2y plus 8 minus 5y equals 2. Combine like terms. I have 2y and negative 5y, so that's negative 3y. I'm going to do another step here. I can subtract the 8, which would be negative 6. Divide both sides by negative 3, and y equals 2. And then this equation looks easier to plug into, so x equals 2 plus 4, which equals 6. So 6, 2 would be my solution. Number 5. Two standard forms. I have a same coefficient with opposite signs, so these are going to automatically cancel out. And then that gives me 9x equals 14 minus 41, negative 27. Divide both sides by 9, x equals negative 3. In this case, neither one looks easier than the other one, so I'm just going to use the top one. 2 times negative 3 plus 5y. Always be very cognizant about which variable you have, because if you were to plug this in to the y on accident, you're going to, of course, not get the right answer. So just make sure that you're paying attention to the details. It can be easy to get kind of ahead of yourself. So 2 times negative 3 was negative 6. Add that to both sides. 5y is 20, so y equals 4. So then my solution would be negative 3, 4. Moving on to number 6. Okay, I have two equations in slope-intercept form. So you have a few options. You can either graph them. If you were to graph them, you would look for the intersection point on the graph, or look in the table and find where the two y values are the same. Or you can use the special substitution method, setting them equal to each other. I'm going to do that just because I don't have a graph. I don't want to pull up the calculator to show you the graph. But before we start, I hope you notice that these are the same slope. So if you already know that, and you know they're the same slope, you should already know what your answer is going to be. But we'll do it anyway. So 2x minus 5 equals 2x plus 10, setting them equal to each other. Subtract 2x from both sides. Cancel, cancel. Negative 5 equals 10, which is not true, doesn't make sense, in which case, no solution. So, you should have already known that because they're parallel lines. Number 7. In this case, we have x's that are being isolated. So this is another example of you can set the equations equal to each other. So essentially it's a method of substitution because this equals x, so I can replace it for the x. So I have 6y plus 13 equals negative 2y plus 5. I'm going to add 2y to both sides. So 8y plus 13 equals 5. Subtract 13. 8y equals negative 8. So y equals negative 1. Again, neither one is particularly easier or harder. These are smaller numbers, so I'm just going to use that one. It doesn't matter. Negative 2 times negative 1 plus 5. Negative 2 times negative 1 is a positive 2 plus 5 is 7, so x is 7. Boop. So 7, negative 1 would be the solution. Number 8. So standard form, no same coefficients, so we can't use a -1. I can't multiply anything times 4 to get to 6 or anything times 5 to get to 9, so I'm going to have to multiply both. These have a smaller common multiple than these do, so I'm going to use these and I'm going to get to 12. So I'm going to multiply the top equation by -2 and the bottom equation by 3. So I'm going to do that. Do it. Come back to me. So this is going to be my new system. I have opposites here that will cancel. I have 37y equals -75. Something is not right. 74. Messed that up. Let's see. 74. Okay. Divided by 37. So y equals -2. And then pick one of the original equations. I'm going to use that top one. 6x minus 5 times -2 equals 28. 6x plus 10. Subtract 10 from both sides. 6x equals 18. X equals 3. So we have 3, -2. And the last one. Again, I have two equations in y equals. I could graph it. I personally feel like I can solve the system faster than I can putting it into the calculator, looking at the graph, analyzing, finding it in the table. I think I can just do the math part faster, especially because there's no fractions, there's no decimals. These are super easy numbers. So I'm just going to set these two equations equal to each other. You absolutely can use the calculator or even use it to check. I'm going to add 2x to each side. Add 2 to both sides. Divide both sides by 3. And then I'm going to replace into the bottom equation. 8/3 minus 2. So 8/3 is really like 2 2/3. So 2 2/3 minus 2, y would just be 2/3. So if you had used a graph or the table, you might not have been able, oops, this is a 2/3. You might not have been able to find that very easily. You would have had to change your table to thirds, which might have taken you a while to figure that out, or use the shortcut on the graph to solve for the intersection. I'm not saying it's impossible, just things you have to keep in mind. But I believe this was probably faster than trying to use it in this case. So that is all.